Okay, in this problem, we're filling a cone that has a base radius of 2 meters and a height of 4 meters. We're filling a cone at a rate of 2 meters cubed per minute. How fast is the water rising when the water is 3 meters deep? So in other words, when this height right here is equal to 3 meters, how fast is it approaching the top? How fast is it rising? So let's take a look at what we know. I definitely have a rate of 2 meters cubed per minute. So that is the change in the volume over the change in the time at 2 meters cubed per minute. Okay, so let's give some labels. I'm going to do this in blue. So we have a couple, and this cone is poorly drawn, but that is the height, and so we know that to be 4, okay? So that matches up with this. Whatever level the water gets to, like right there, whatever level the water gets to, that also has a radius. And that radius is different than the 2 because the closer you get to the top, the closer the radius is going to be to 2, but it's not going to stay 2. That radius changes the farther up you go. So we'll call that radius R. Now the height at which this is coming as well, we'll call that H. So really what we've got is 2 levels. If you take a cross section of the cone, we got the total height is 4 and the total radius is 2, but we have this in between that looks like R and H. And now this should be looking to you for classification purposes like a similar triangles problem. So I don't know how quickly dr is changing. I don't know how quickly the height is changing. What I do know is how fast is the water rising is that dH over dt. Is that dH over dt. I also know that the volume of a cube, which I do have the dV over dt, is 1/3 pi r squared h. So I don't have a dr by dt, and I don't have a dH by dt. So this is a similar problem to what we did in the class, where if I go ahead and do this implicitly, I'm going to end up with 2 rates that I don't know. But I also know that I can relate R and H to each other by this similar triangle. So when I find the dV by dt, I'm going to have dr by dt and dH by dt, which I don't know. In fact, I'm looking for dH by dt as the answer to my problem, but I can relate how they're responding to each other through those similar triangles proportions. So let me flip to another screen. We draw that triangle for perspective purposes. So to draw that, remember, in class I did it big to little. So it would be 2 goes to R as 4 goes to H, which makes 2H equals 4R. And we can divide out the 2 so that H goes to 2R, and so that R is equal to H over 2. Now that I have this, I can take this formula and I can apply the operator. dr by dt equals 1/2 dH by dt, because 2 is just a constant. So why is this critical, and why did I do it? Why did I isolate the R? Well, I want to find out what R is in terms of H, and I want to know what dr is in terms of dH by dt, because that will allow me to eliminate all dr by dt's in place of dH by dt, and moreover, I can eliminate all the r's by applying the h. And we can solve the problem that way. Okay, so let's bring back volume equals 1/3 pi r squared h. So unfortunately, this is going to involve implicit and product. Now, 1/3 and pi are constants, so I am going to apply the operator so that dv by dt is equal to 1/3 pi, and I'm going to apply the operator to r squared h. So dv by dt equals 1/3 pi, or we'll call it pi over 3 for simplicity's sake. So this is going to be 2r dr by dt times h plus r squared times the derivative of h is just 1 dh by dt. So now you can see I have two differing rates right here and right here, and I don't know what those rates are, so I'm going to use this relationship to replace that dr by dt. All right, I shrunk it up so I have a little bit more space to work, but I am working basically from right here. All right, so now I'm going to use this relationship, and I can even, to get it into a single variable, I can even use this relationship to get rid of the r's, because I know the height in this case is 3. And so you have a couple choices. You can either just plug it in directly, or from that height equals 3, you can also, from here, if height is 3, radius must be 3/2. So you can sub those in directly, whichever way you want to go about it, or you could change out these r's variable for h's as you see fit. Regardless, I also know dv by dt from the previous page. dv by dt in this case was 2. So this becomes 2 equals pi over 3. And this is going to be 2. And I now know r is 3 over 2. And I now know dr over dt is 1/2 dh over dt. Get rid of that. Nope. Won't let me. dt, apologize for that. And then this is going to be times h, and an h in this case is 3. And then we're going to go plus, I have r squared, which is 3 over 2. Squared, and I have dh over dt. Okay, so I'm going to do some simplifying here at this point. I'm going to bring this pi over 3 over, so it's 6 over pi, just to get rid of it for a second. These 2's divide out, so I'm left with 9 over 2 dh over dt, and then 3 over 2 squared is 9 over 4 dh by dt. So that's here, I could make that 18 over 4, and then that becomes 27 over 4 dh by dt. So dh by dt, if I isolate it, is going to be 6 over pi times 4 over 27. So I could divide by 3's to get 2 and 9. So that becomes 8 over 9 pi equals dh over dt. So height over time, height was in meters. Time was in minutes, so the height is 8 over 9 pi meters per minute. And that's how quickly the height is changing.